everyone, welcome back to my channel. My name is Noy from ABABA University. Today I'm gonna show you how to solve this problem. As you can see, this problem is all about the concept of relative motions. Before starting today's tutorial, if you are new for educational YouTube, make sure to subscribe our YouTube channel in order to access free engineering problem solutions and tutorial. For now, let's jump into this problem. A small ship capable of making a speed of 6 knots, which means the speed of this ship is 6 knots. Through a rotor maintain a heading to east, which means this is moving around these directions. To east while being set to the south of an ocean current. An ocean current in this direction, and the actual course of the boat is A to B. From A to B, we discover this the distance 10 nautical mile in 2 hours. Determine the BC, which means the speed from here to here, and the angle, which means the direction measured from clockwise from the north degree. In order to solve this problem, we can use different methods, but I am showing you how can solve this problem by using the concept of cosine and law. It's very important and trigonometrics. So we can apply application of sine and cosine law. Finally solve this problem. Before using this two very important equation, we must know about the given quantity. Here we are given the speed of B, which is 6 knots, and the distance between A to B is 10 nautical miles, and the time taken in order to cover this distance is 2 hours. Then we can simply calculate BC by using the concept of cosine law, and the direction measured from clockwise by using the concept of sine law. In order to apply the cosine law, first we must determine the velocity of P with respect to C in this direction. So velocity of P with respect to C is the distance over time, which is 10 nautical mile. It's covered into hours is 10 over 2, simply is 5 knots. Then the velocity of the river is the required one. The velocity of the river is the required one, and we can apply the cosine law for triangle in AOBE, not OBE. Then we can calculate this BC value, because we know BBC and the angle between BC and VBC. Simply you can substitute the value, and we can get the value of BC. Then BC is equal to 1 under radical VB square plus VB with respect to C square minus 2 times VB times the velocity of B with respect to C times the angle between the velocity of B times the velocity of B with respect to C is 10 degrees. Then we can substitute the value 6 squared plus 10 over 2 square, which is 5 square, minus 2 times 6 times 10 over 2 is 5 times cos 10 degree. After simplifying this problem, we get 6 square plus 5 square minus 2 times 6 times 5 times cos 10 degree, which is 61 minus 59.08 degrees. Simply we can get 1.385 something. This is our BC, or the velocity of the rivers. So it is very easy method in order to determine the velocity of the river by using the cosine law of triangle AOBE. Then we can determine the direction measured from the clockwise from the north by using the concept of sine law. Now let's jump into this. So in order to determine the direction theta measured or clockwise from the north degree, which means we can take north at 0 degree, I can apply the sine law for triangle OBE. Here we can see OBE, and we can ask to determine the angle theta. Then we can VB over sin theta equals to VC over sin theta, which means VB, here we have velocity of B, and here we have sin theta, here we have sin theta, and here we have velocity of VC, which is already found before. It's around 1.3 something times sin tens. Then the three things are known. We can simply find sin theta. From this we can use the inverse of theta, and we can simply calculate the angle or the direction from the north. Then theta is cosine inverse of VC, not this is VC, it is VB over VC. You can correct it by yourself. Then sine inverse of 6 times sine 10 over 1.33 equals to sine inverse of 1.